basic sine graph and a basic cos graph, what they look like, that you can take them off of the unit circle, all that jazz. I'm gonna say I'm seeing more phones than I'd like to. I know I'm not that interesting, but I'm awesome. So if you'd like to pay attention. Oh, there we go. All right. So amplitude and period. We looked at the amplitude and the period, and we discussed that the period of a basic sine graph and cos graph took till it rotated around a whole circle, right? Which was 2 pi or 360. We also said that a basic sine and cos graph went from -1 to 1. So the amplitude was 1 because the amplitude's half the distance, right? We agreed to that. So that's if off a graph, you can figure out the period and the amplitude just based on looking at it, correct? Till it takes to repeat itself, half the distance from min to max. But what if we're given an equation? On an equation, the a value here, if you take the absolute value of the a value, you get the amplitude. So actually, off an equation, the amplitude's really, really, really easy because it's just whatever a is. Well, the absolute value of a. So if a is negative, you would just take the absolute value of it and it's positive. Amplitude always has to be positive because it's a distance. Okay? So that's really easy. If you're given an equation, there's nothing easier than being asked the amplitude, right? Absolute value of a, done. The period, how do we get the period off the graph? Well, it's going to be this formula or this formula should have a little degree symbol. It's going to be 2 pi divided by the absolute value of b, or 360 divided by the absolute value of b, depending on what your equation is in. If your equation is in radians, you'd use 2 pi. If your equation was in degrees, you'd use 360. Okay? Now, why would that be the case? Why would I take 2 pi and divide it by b to get the period, or 360 and divide it by b? B is what in this equation? What would your b be? Y equals a sine b theta. What is the b representative of in transformations? Because remember, transformations never leaves us. It stays here for life. It's in every unit. I told you that. What is the b? It's in front of the variable in the brackets. So what does it represent? What kind of stretch? A horizontal stretch, right? It's a horizontal stretch, and it's the flip of that. We agree? So let's think about this. If our graph is normally 2 pi or 3 pi, if I stretch it by a factor of 2, the period is going to be twice as big, right? If I stretch it by a factor of a half, it's going to be half as big. So instead of 2 pi, it'd be pi, or instead of 2 pi, it'd be 4 pi if I stretched it, correct? Well, why are we dividing by that b? Because it would be technically 1 over b. So we're actually multiplying by the reciprocal by dividing by it, right? So we divide by that b because that's actually multiplying by the horizontal stretch. We agree? So normal sines and cos, if the b value is 1, will always be 2 pi or 360. But they're split up if our b is an actual value because the graph has a horizontal stretch. And what affects the period? The period is how long it takes to repeat itself horizontally, right? So would a vertical stretch affect that at all? No, the only thing that's going to affect that period, that how long it takes to repeat itself, is if I squish it or I make it longer, right? Which is the horizontal stretch. So that's why you have to use these formulas when you're given an equation and asked for the period. Okay? So we need to state the period and the amplitude of each. So what's the amplitude of A here? The absolute value of 2, which is 2. What's my amplitude of B? It's 1/2, because it's the absolute value of a half, which is a half. Right? How do they make it harder? They make A be negative and see if you pick amplitude to be negative. But it can never be negative, right? Amplitude, so it's positive, it's a distance. Just like the radius on the unit circle is positive, or the radius on any of those drawings we do within the unit circle, or the Cartesian plane. Okay, the period is how long it takes to repeat itself, correct? This graph is horizontally stretched by a factor of what? 1/3. So the period is going to actually be narrower than 2 pi, is it not? Because we're taking it from being 2 pi and we're squishing it to 1/3 of its width. We agree? So if we go 2 pi divided by b, what's b in this case? 3. Or we did 2 pi multiplied by 1/3, right? It's the same thing. Dividing by 3 or multiplying by 1/3. It's the same thing. So our new period is 2 pi thirds, which makes sense. It's 1/3 of what it was. It's 2 pi. It's now 2 pi over 3. That's how long it takes to repeat itself. So it's going to repeat itself more in that same amount of time. We agree? Okay, this one has a half. So I'm going to use 360 in this case. So the period equals 360 divided by a half. Why are we dividing by a half? Because it's a horizontal stretch by a factor of 2, which is actually multiplying it by 2. It's getting wider, is it not? So it's now going to be at 720 degrees. So you divide by the b value so that it actually affects it horizontally correctly, right? Does that make sense? Because we always flip that horizontal stretch. Always, always, always. Pardon? Degrees? I just chose to do degrees. The only way you're actually going to know if it's in degrees or radians is if they specify or by the c value. So, bless you. They have y equals a sine b, and then they'll have like x plus 30 degrees. The c value is the horizontal shift. So if this is in degrees, you know it's degrees. Or x plus pi over 6, then you would know it was in radians. But if they don't give you a c value, they kind of have to tell you. Or the answers will be radians or degrees, right? It could be 4 pi as well. Yeah. And either would be okay because there's no specification. Yeah. Okay. So what transformations occurred? Who cares if it says cos or sine or tan in there? Don't let that throw you off. You know A is a vertical stretch and reflection in the x-axis. You know B is a horizontal stretch and reflection in the y-axis. You know C is a horizontal translation. You know D is your vertical translation, right? That has not changed. It doesn't matter what unit we're in. Those stay the same. So it's wonderful. Transformations at first is annoying. But the great thing about it is that it keeps doing the exact same thing over and over and over. It doesn't shift because it's a trig question. Okay? So what transformation is this? This is in front. Is it with the x? No, it's in front. So what kind of stretch is it? Vertical stretch by a factor of. Now, if this was a written response and you put BSBA, baffle, would I give you full marks? No, because you're assuming I know what the heck that stands for, and well, it's a good assumption since I made it up. But nonetheless, you have to pretend at all times when you're writing your test that the person marking it has no clue what the heck those stand for. Like there's no dictionary in the world that VS always means vertical stretch. Okay? Yes? So we need to write vertical stretch by a factor of. You can't use lingo in unit tests. Vertical stretch by a factor of 2 about the x-axis. And you have to put about the x-axis because it's about the x-axis. You can't assume I know what axis it is. You know what I assume when you don't put x-axis? I assume you don't know which one, so you're hoping I'm going to give you a full mark by just not putting it. So you can't get it wrong if you don't put it, and Mrs. Lepp will give me the full mark. She's not going to. She's me. I'm not going to. I know what I'm going to do. Okay? So we need to write it out. Now, what's the amplitude of this particular question? 2. Now, what affects the amplitude, or what does the amplitude, sorry, affect on the graph? Well, the amplitude now, normally it was 1, right? On all those other graphs, it was a distance of 2. We split it in half. It was 1 and 1. But now it's actually a distance of 2. So it's making the graph taller, which makes sense. I'm vertically stretching it by 2. I'm making it wider. We agree? Okay. Now, this particular graph has not been translated up or down at all, has it? So the graph is normally about y equals 0, is it not? And the other graphs were up 1 and down 1. We agree? We maxed out at 1. We minned out at -1. Has this been shifted up or down at all? Is there a vertical translation at the back, like a +6 or a -2 or anything? No, it hasn't moved up or down at all, has it? So instead of it being to +1, it's now going to be to +2. And instead of it being to -1, it's now going to be to -2. I have my range. My range is between -2 and 2. I'll switch back and forth between interval and set as we do each question. What's the period of this graph? What affects the period? Your period is the graph that does this, right? Either squishing it or widening it affects it. If not, it's 2 pi or 360, correct? Do I have any squishing or widening happening? Do I have a horizontal stretch at all? So what's my period going to be? 2 pi or 360. And we could prove it by going 2 pi divided by b, which is 1, or 360 divided by b, which is 1. So it's going to be 2 pi or 360, correct? But we know that if there's no horizontal stretch, the graph is not getting wider or narrower. It's 2 pi, 360. Okay? What's the domain of this? What's the domain of every trig unless I restrict it? XCR. So I'll use interval notation for this one too. Okay. We're going to practice typing these into our calculator so we know what they look like. Go to your y equals. Y equals. I'm going to pause this and get mine. Put down your marker. Okay, so what was our equation? 2 cos x. I pressed the cos button, so what do I need to make sure I'm in? The correct mode of whatever it is, okay? For this instance, we're going to do a degree, just to understand it a little better. So I'm going to go mode, and I'm going to go to degree. I'm going to hit enter. Now, my window is easy to make at this point. Let's think about it. I know I maxed out at what? Because I told you the amplitude, and I didn't move up or down. I maxed out at 2. So I'm going to do my y's first because those are often easier. So I minned out at -2. I maxed out at 2, right? I can make my scale be 1. I can make my scale be 0.5, whatever. The scale isn't as essential. Now, if I want to see one curve of the graph, I need to at least have the period of the graph, right? What was the period of this graph? 360, right? Because we're doing degrees. So I'm going to put in 0, and I'm going to put in 720. And the reason why is I like, whoa, that's way too much. I like seeing at least 2. And I'm going to make the ticks go up by 30s. Okay? It's a lot easier to set your window if we're in degrees, so that's why I'm starting with degrees and go to radians as we go along. Press graph. And there I have my curve. Now, it says on there that I want the x-intercept. What's the x-intercept? Well, I need to do a general solution, correct? Because it didn't limit me. So we need to find the first positive what? X-intercept. The first positive. So let's go use our calculators. Everyone's touching these buttons so they all can do this. We need to find the first x-intercept. There's 2 ways you can do this. One way, you can do second trace 0, left bound, right bound. Second way, when you're finding your x-intercepts, you're finding where it crosses and intersects with the line y equals 0, correct? So that's what I like doing, and this one's colored, so I'm going to do that. So I'm going to make my y2 be 0. Now, if you're math entering like on 5 all the time, and you're like, it doesn't work, it's not intersecting, but you have one equation, you can only use 5, second trace 5, enter, 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 to intersect between 2 equations. If you only have one equation, it will never work. So you're trying to get your calculator to do something that it has no clue what you're doing. So you have to put in a second equation. I'm going to put in 0. Now I'm going to press graph. Do you see how they're blue and red? I'm going to find out where they intersect, and I get my x-intercepts that way. If not, you can do second trace 0, left bound, right bound, totally gets it for you. Okay? Same thing. So second trace 5. I'm going to find out where they intersect. I need to move closer. So now, if you're doing this, please pay attention, because I did this my whole entire career and had no idea I could be getting. You're going to hold it for forever, right? Or a faster way, path of least resistance, would be to get on the red line and shoot across, correct? It's going to take longer to get to this intersection if I follow blue than red, is it not? So arrow down, get on red, climb over. way faster. You don't have to do the curve just because it's on it. You can revolt and do what you want. So my first one's at what? 90. Okay? Now I need to find out when the next one happens. So second trace, 5. Oh, path of least resistance. I want to go this way. As long as I'm closer to it, it will calculate it. 270. How far apart are they? 180. So if you have to do them in degree mode to make it make more sense to you first and then convert, go for it. I don't really care. Okay? If they wanted it in radians, let's say. All right. So our first x-intercept is, what's our variable? Our variable is x, okay? If our variable was theta, we'd say theta equals. Our variable is x. So we're going to say x equals 90, because that's our first positive, plus, how often do they happen? 180 n NEI. What's my y-intercept at? Looks like it's at 2 on the graph, doesn't it? How can we prove it? How can we find y-intercepts on our graph? Well, we can go second, trace, put down your marker. That's not going to work for you. Second trace, value. And the reason why you use the value button is it's x equals. When you find the y-intercept, what does x equal? 0. And it's at 2, proving we're correct. Okay. How could the amplitude and the range be obtained without the graph? This is the key thing here. Paying attention. Okay. So this is something that everyone forgets. We're going to star this so that we remember this little rule, because if they give us variables, this is the fastest way. We need, in order to do the range, we need the maximum and the minimum, correct? If we do a range of any function, the range of any function is y such that the minimum is less than or equal to y is less than or equal to the maximum yer. We just need to find out what those numbers are, correct? Or in interval notation, it's min comma max. And once we know those numbers, we have the range, correct? So right now, what we can look at, and you're going to have to trust me, is there's something called the midline. The midline is what cuts the graph in half, and we're going to discuss it more tomorrow because it's the d value. The d value is what's the line that cuts the graph in half. So it's this horizontal line here. The d value in this case is 0, is it not? So if I take that value of 0, if it was higher, or 1 or 2 or 3, it's the part that cuts the graph in half. We agree? If I take 0 and I add to it my amplitude, what do I get to? My max. And if I take 0, my d value, and I subtract from it my amplitude, what do I get? My min. So to get the max and min easily, I can go to get my max, I'm going to do d plus amplitude. So in this case, it's 0 plus 2, so my max is at 2. My minimum is going to be d minus the amplitude. So in this case, 0 minus 2. So it's -2. Didn't have to plug in my calculator at all, and it gave me my min and my max. Okay? Always works. Everyone forgets about it. So I'm going to start a few times. Because they could give you an equation with full variables and ask you for the min and the max, or the domain and the range. And there's absolutely no numbers. You can't plug in your calculator. You can't find the max and min by going second trace max, left bound, right bound, because it's all letters. Okay, let's look at y equals sine 3x. What's my amplitude in this case? What's my a value? It has to be a 1. Some people tell me 0. First off, if it's 0, that means you have a horizontal line, because it's not going up or down at all, right? It's just 0. That's not a sinusoidal graph. That's a horizontal line. So our amplitude is 1. What's our range? Yeah. So I'm going to go max. What's my d value? 0, right? So my maximum is going to be 0 plus 1, which is 1. And my minimum is 0 minus 1, which is -1. Why did they say it 1 and -1 and the last one didn't? What's the difference between this equation and the last one? This one doesn't have a vertical stretch. It has not been pulled up anymore, right? It's negative 1 to 1. Yeah. What's the period of this graph? We do it in radians. 2 pi over 3. P equals. What's my domain? XER. For the first box, what's my transformations? There's only a horizontal stretch by a factor of 1/3 about the y-axis, which makes sense. It's stretched by 1/3. It's being narrowed, right? It was at 2 pi. It's at now 2 pi divided by 3 because we'd multiplied by 1/3 everything, right? Crystal clear? Okay. We're going to go down to here. Skip ahead a little bit. So, give the number of cycles. Cycles are periods. How many periods happen in X number of time? Okay. Give the number of cycles within the original period for each of the following equations and the period, both degrees and radians, based on the formula above. So what's the amplitude in number 1 here? 3. My amplitude is always the absolute value of A. So in this case, it's the absolute value of 3. So it's 3. So I go up 3, I go down 3, right? And what's my D? It's 0. So I'm still symmetrical about that x-axis. So I'm up 3, down 3, right? Okay, what's the period in degrees? 360 divided by 2, which is 180. Does that make sense? I horizontally stretched it by a factor of 1/2. It was at 360, I halved it. 180. Makes sense. In radians, it's 2 pi divided by 2, which is pi, which makes sense. So the regular sine graph and cos graph repeats themselves every 2 pi. So how many times is this one going to repeat itself in 2 pi? It repeats itself every pi twice. 2 cos 3x. My amplitude equals the absolute value of 2, which is 2. My period. This one has a horizontal stretch by a factor of what? 1/3. So it's narrowing, is it not? So my period is 360 divided by 3, which is 120, or 2 pi divided by 3. How many times is it repeating itself? 3. What's the amplitude of this one? Absolute value of -3, so it's 3. Amplitude is always positive. This one is being horizontally stretched by a factor of what? 2, so it's getting doubled. It's getting wider, right? So the period is 360 divided by 1/2, or multiplied by 2, which we knew, or 2 pi divided by 1/2, or multiplied by 2, which is 4 pi. So how much? The number of cycles within the original is half. Half the cycle in the original. This one, the amplitude equals absolute value of 1/2, which is 1/2. The period equals 360 divided by 1/4, which is 1440. And then 2 pi divided by 1/4, which is 8 pi. So how many times does this one repeat itself? 1/4. You see how they match up with B, right? All right.